So whether the reaction will take place or not and to what extent the reaction will take place, we'll get to know using thermodynamics in equilibrium. Initially, what was the reactant's concentration? Finally, what is the concentration of the reactant? The difference divided by the time difference will give you what? The rate of the reaction. There is a decrease in concentration of a reactant, so it is important to mention this negative sign here. Hello everyone, this is Ambli Unnikrishnan from the Department of Chemistry. So today I am back with the third chapter of your syllabus, that is Chemical Kinetics. So this is a new branch of chemistry for you, that is Chemical Kinetics. So let us understand what we are going to study in this chapter first, that is what is chemical kinetics. Later we will be studying what is rate of chemical reaction, what is average rate of reaction, instantaneous rate of reaction, factors which affects the rate of reaction, dependence of rate on reaction, rate constant and characteristics of rate constant. All this we are going to study in this chapter. So before moving on to the details of chemical kinetics, generally when we talk about a chemical reaction, there are few or three concepts that we majorly talk about when we discuss about any chemical reaction. First one is whether the reaction will take place or not, which is known as a feasibility of a reaction, whether the reaction is feasible or not. That is, the feasibility of a chemical reaction can be predicted using thermodynamics. Thermodynamics we have already studied in your first PUC, right? So, if the delta G value, Gibbs free energy value is less than 0, we can say that the reaction is feasible. So, using thermodynamics, we will get to know whether the reaction is feasible or not, that is, whether the reaction can take place or not. The next one is extent of a reaction. That means to what extent the product will be formed or to what extent the reaction will proceed. The extent to which a reaction will proceed can be determined by chemical equilibrium. Equilibrium also we have studied. So to what extent the product will be formed or to what extent the reaction will proceed, we will get to know using thermodynamics. So whether the reaction will take place or not and to what extent the reaction will take place, we'll get to know using thermodynamics in equilibrium. Now the next factor regarding chemical reaction is what is the speed of this reaction. Okay, that is what the time taken by the reaction to reach equilibrium. So how fast or how slow the reaction will take place, that also we need to know. So the speed of the reaction, regarding this we are going to study in chemical kinetics chapter, right? So what is chemical kinetics then? It is a branch of chemistry that deals with the rate of the reaction. So in chemistry we will not be using the word speed, we will be using rate. So rate actually it means speed itself, that is the how fast or how slow the reaction is going to take place. Factors influencing the rate of reaction also we will be studying in this branch. So in chemical kinetics we are going to study about the rate or speed of the reactions, right? So the word kinetics is derived from the Greek word kinesis, meaning movement. Thermodynamics tells us only about the feasibility of a reaction, whereas chemical kinetics tells about the rate of the reaction. So I hope you are clear with that. What we are going to study here, it is about the rate of the reaction or speed of the reaction, right? So let us begin with the rate of chemical reaction. Let us understand what is the rate of a chemical reaction. The rate of chemical reaction is the change in concentration of reactants or products in unit time. So it is change in concentration of reactants or product in unit time. So let us compare it with physics. What, as I told you, rate means speed itself, right? So speed, according to physics, what was speed? Speed is distance by time, right? Speed is distance by time. So what is this distance? How we can measure? That is how much the distance have covered, that is the final distance minus the initial distance. If we take the difference, we'll get the distance divided by the time taken. We'll get the speed. Same way, in case of physics, it was the distance. In case of chemistry, when we are coming, we are talking about chemical reactions, right? So in chemical reactions, what is going to happen? Reactants will be there initially and they will combine together to form products, right? So the change in concentration of this reactants or change in concentration of the products in a given time or in unit time is called as the rate of the reaction, right? Initially, what was the reactant's concentration? Finally, what is the concentration of the reactant? The difference divided by the time difference will give you what? The rate of the reaction, right? Okay. So in physics, it was distance. In chemistry, we are dealing with concentration of reactants and products. So either you can expressed in terms of concentration of reactants or concentration of products. It decreases in concentration of reactants in unit time, or else it is increase in concentration of products in unit time. Now what is this? It is decrease in concentration of reactants in unit time. When we are talking in terms of concentration of reactants concentration is going to decrease, right? Initially the concentration of a reactant, you can see in this graph also, the concentration of a reactant, a value will be there initially. Then what will happen? Reactants will combine together and form product. So what is happening here? Reactants is getting used up. So the concentration of the reactants will keep decreasing, right? And what will happen to the concentration of the products? Initially, there will not be any products, only reactants will be there. So products concentration will be 0. There are no products. Then what will happen? Reactants will get used up and products will start forming. So what will happen? The concentration of the products will start increasing. So this is what is happening. So in terms of concentration of the reactants, it is going to decrease in unit time, and products, it is going to increase in unit time. So for a general equation, we can take AA plus BB giving CC plus DD, wherein A and B, capital A and B are reactants, capital C and D are products, and the small a, b, c, d are the number of moles. So rate, we can either write it as change in concentration of reactants by time, or else change in concentration of products by time. So in either way we can represent. So change in concentration of reactants by time or change in concentration of products by time. Now moving on to the next one, that is average rate of a reaction. Same way we have studied in physics also, average speed of a reaction. Same way we are going to study here also, what is average rate of a reaction. It is a change in concentration of reactant or product in unit time. Let us consider reactants giving products. That is R is giving P. R is a reactant, P is the product. At time T1, let the concentration of the reactant be R1 and that of product be P1. And at time T2, let the concentration of reactant be R2 and P2. So you can see here it is mentioned in the, or it is expressed in square brackets. So the square brackets mention the concentration. Okay. So whenever you are mentioning the concentration, it must be put in square brackets. So at time T1, R1 and P1 be the concentration of reactant and product, and at time T2, R2 and P2 be the concentration of the product and the reactant. Now delta T stands for the change in time, that is T2 minus T1, right? Now what is the change in concentration of reactant? It will be R2 minus R1. And what will be the change in concentration of product? It will be P2 minus P1, right? Now rate of disappearance of R. What is rate of disappearance of R? Why it is written disappearance? Because the concentration of the reactants is going to decrease, right? So that is decrease in concentration of R by time taken. That means it is minus delta R by delta T. So delta R means what? It is R2 minus R1 itself, right? R2 minus R1 by T2 minus T1. That is what is written here, delta R by delta T. This is average rate of a reaction, right? Now you can see one more thing here, why there is a negative sign here, right? Why there is a negative sign? Because there is decrease in concentration of the reactants, right? There is a decrease in concentration of reactants, so it is important to mention this negative sign here. Now rate of appearance of P. Product, what is going to happen? Concentration of product is going to increase. So it is increase in concentration of P by time taken. So what is that? Change in concentration of products, delta P, right? Delta P by delta P. So you can also write it as P2 minus P1 divided by T2 minus T2. Right. So you mention it using delta, that is average rate of a reaction. Now let's take for a general reaction. For a chemical reaction AA plus BB giving CC plus DD, average rate of a reaction is given as minus 1 by A by delta T is equal to minus 1 by B delta B by delta T is equal to 1 by C delta C by delta T is equal to 1 by D delta T by delta T. Now what is this? We already know how to represent the average rate of a reaction. That is what is given here, minus delta R by delta T or else delta P by delta T. Now you have the reactants here and products here. Now if you have to write the average rate of a reaction, this number of moles you can see here, A, B and C, D, small letter A, B and C, D, the inverse of that must be written as the coefficient of this average rate of reaction. So how do you write the average rate of reaction? In terms of A, it will be minus 1 by A. This A's inverse you have to take. So it is minus 1 by A into delta A by delta T. That is average rate. So this minus 1 by A have to be multiplied. Why again there is a minus here? Because it is reactant. Now moving on to, it is equal to minus 1 by B. That is for this reactant B. Minus 1 by B delta B by delta T is equal to. Now what about these products C and D? There is no need of negative sign there. So it is 1 by C into delta C by delta D is equal to 1 by D into delta D by delta T. Okay. So you can write it in this form. Now for example, let us take 2HI. 2 moles of hydrogen iodide forms iodine gas and hydrogen gas. Now what will be the rate of the reaction? Average rate of the reaction, how you can write. So this 2, what you will do with this 2? This is the reactant. Hydrogen iodide is a reactant. You have to take the inverse of it. And as it is a reactant, you have to put a negative sign also. So it will be minus 1 by 2 delta HI by delta T, which is equal to, now which are the products here? Iodine and hydrogen, right? So are there any coefficients here? No. So it is 1 by 1 itself. So it is 1 itself. So you need not write 1 by 1. So what it will be? And there is no negative sign also. So it will be delta I2 by delta T, which is equal to delta concentration of hydrogen gas by delta T. So I hope this is clear. So this is how you mention the average rate of the reaction. So whichever coefficients you are having, you have to take an inverse of that. Now moving on to the next one, that is instantaneous rate of a reaction. Now it is the rate of change of concentration of a reactant or product at a particular instant of time. Okay, earlier we were discussing average rate of a reaction. Now what is instantaneous rate? At an instant or at a particular time, what is the change in concentration of the reactants or products? That is called as the instantaneous rate. Now, what is the difference in representing average and instantaneous rate? Instantaneous rate, it is in the form of differential, d by dt, right? So, if for example, we are taking reactants giving products. This is the equation. Then how do you write? The instantaneous rate is minus d by dt of concentration of R, which is equal to d by dt of concentration of products. So again, negative sign here because it is reactants. So average, it was delta. Here you use d by dt. Right. Now for a chemical reaction, AA plus BB giving CC plus DD. Again, what we have to do with this A, B, C and D? We have to take the inverse of that. So instantaneous rate will be minus 1 by A dA by dt and minus 1 by V dB by dt equal to 1 by C d by dt of C equal to 1 by D d by dt of D. So here you can see negative sign because these two are reactants. So this is how you have to represent the instantaneous rate of a reaction. So you can see the graph here. So the first one you can see, that is concentration of the reactant versus time. Okay. So initially the concentration was here R0. Now what happens? As the reaction proceeds, the concentration will decrease. Okay, the concentration will decrease. So, the average rate of a reaction, how you can represent it? It is minus delta R by delta T. So, minus delta R means the final concentration is here C2 and the initial concentration we have taken is C1. So, it will be minus of C2 minus C1 by T2 minus T1. So, you have the T2 here and T1 here. Okay, so at T2, what is the concentration? C2, and at T1, what is the concentration? C1. So, it is minus of, so do not forget to put this minus sign because it is reactants. C2 minus C1 divided by T2 minus T1. Now, what is R instant? That is instantaneous rate. So, how do you calculate instantaneous rate? At an instant. For example, at this point we require, what we'll do? We'll take a slope there. You have a graph here. We are going to take the slope of this graph and the slope will give you the instantaneous rate. Now, that instantaneous rate we can calculate it by the slope, that is minus of slope. Again, minus because it is reactant. So, what is that? Minus d by dt of R. So, we will get the instantaneous rate of reactant. Now, coming on to product. Initially, the concentration of product will be 0 and as the reaction proceeds, the concentration of products is going to increase. Now, again at T1, the concentration of the product is C1. At T2, the concentration of the product is C2. Now, average rate, how do you write it? Is delta P by delta T. That is C2 minus C1 divided by T2 minus C1. No negative sign required. Now, instantaneous rate. For at this point, if you want, we will take the slope of this graph. Again, from the slope of the graph, we will get dP by dt, that is instantaneous rate. I hope it is clear. So, if you have to calculate the instantaneous rate from the graph, you have to take the slope of the graph. Now, moving on to the unit of rate of reaction. Now, how do you calculate the unit of rate of reaction? Rate is equal to change in concentration of reactants or products divided by time. So, we have to see what is the unit of concentration. It is moles per liter, right? Moles per liter is the unit of concentration. Now what is the unit of time? It is second. Now we take the second to the numerator. So what will be your unit? It will be mole liter inverse second inverse. Right, mole liter inverse second inverse. So instead of writing mole per liter, I have written mole liter inverse. So this is the unit of rate of reaction. Right, mole liter inverse second inverse. Now the factors affecting the rate of reaction. There are various factors which affects the rate of the reaction. First one is the nature of the reactants. Okay, the second one is concentration of reactants. Third one is temperature, pressure, effect of catalyst and influence of radiation. So all these factors affects the rate of the reaction. So we'll be studying concentration of the reactants in detail in this chapter. Right. So the dependence of rate of reaction on concentration we are going to discuss now. The rate law is the expression in which the reaction rate is given in terms of molar concentration of reactants with each term raised to some power which may or may not be equal to the stoichiometric coefficient of the reactants in a balanced chemical equation. So how the concentration of the reactant will affect the rate of the reaction is being expressed by a law which is called as the rate law. Okay. So rate law is an expression which is given in terms of molar concentration of reactants only. It is only the molar concentration of reactants. Okay. And it will be raised to the power which may or may not be equal to its stoichiometric coefficient. So let us take an example and understand this. A general equation has been taken here, AA plus BB giving CC plus DD. So which are the reactants here? A and B. So now what is the rate of the equation? Rate of the equation according to rate law, it is directly proportional to the product of molar concentration of the reactants. Only A and B we are considering, no C and D. Product of molar concentration of the reactants raised to some power which may or may not be equal to its stoichiometric coefficient. Here you can see the stoichiometric coefficients are A and B. But here I have mentioned X and Y. That means it can be A and B or it cannot be A and B. Okay. So now to remove this proportionality, we introduce a constant K. Now this K is called as what? That is called as rate constant. Now K is called as rate constant. So R or rate is equal to K into A raised to X into B raised to Y. So this is called as the rate law. So rate law is an expression which links between rate of the reaction and the molar concentration of the reactants. Right. So rate is equal to K into A to the power X into B to the power Y, where K is the rate constant. The equation which relates rate of a reaction to concentration of the reactant is called as the rate law or rate expression. Right. Now rate is equal to K into A to the power X into B to the power Y. Now rate we already know, we can also represent in form of instantaneous rate, that is minus d by dt of concentration of R. Minus d by dt of R is equal to K into A raised to X into B raised to Y. So this is called as differential rate equation. We can also write it in the form of d by dt, right? That is why it is called as differential rate equation. Rate constant, it is the rate of the reaction when molar concentration of the reactants is unity. So how you can define rate of a reaction? See, rate is equal to K into A to the power X into B to the Y. Power Y. So how can you define the rate constant of a reaction? So if the concentration of A is 1 and concentration of B is 1, what will happen then? Rate will be equal to K because these two factors are 1. So rate will be equal to K. So rate constant is the rate of the reaction when the molar concentration of the reactants is equal to 1. Right. Now let us take few examples here. You can see here 2 moles of NO plus oxygen gives 2 NO2. So how do you write the rate law or rate expression? So the small letter R stands for rate of the reaction. R is equal to K into NO, molar concentration of NO raised to the power 2. So you can see the stoichiometric coefficient which is mentioned here. And molar concentration of O2, any stoichiometric coefficient here? No. So it is just 1. Right. So this is how you have to represent the rate law of this particular equation. So the products do not play a role in rate law expression. Now moving on to the next one. CHCl3 plus Cl2 gives CCl4 plus HCl. Now how do you write the rate law? R is equal to K into molar concentration of CHCl3 into molar concentration of Cl2. Now here you can see molar concentration of Cl2 raised to the power half. But you can see in this particular expression, you are not able to see any half here. It is not shown here. So what does that mean? This rate law, in this, the power of this concentration of reactants, it may or may not be equal to the stoichiometric coefficient. So here you can't see anything, but there is a power which is present here. Now you have CH3COO-C2H5 which is an ester plus water gives acid and alcohol. So here you can see rate is equal to K into molar concentration of the ester into molar concentration of water. So you can see it is raised to the power 0. Any concentration or any term raised to the power 0 is equal to what? 1. So that means here actually a stoichiometric coefficient is there, which is 1, but still the power here which is written as 0. So it may or may not be equal to the stoichiometric coefficient. I hope it is clear. So this is how you represent the rate of the equation, that is R is equal to K into molar concentration of the reactants raised to the powers. Right. Now the characteristics of rate constant, that is K. This K value, the characteristics of K we are going to discuss. It is a measure of rate of the reaction. Higher the value of K, greater is the rate of the reaction. So if rate constant is more, that means the speed of the reaction or the rate of the reaction will be more. A particular reaction has a definite value of K at a particular temperature. So each reaction will have a different value of rate constant, and if you change the temperature, the value of K will change also. Right. The value of rate constant increases with increase in temperature. So what you have to remember, K, that is rate constant, depends upon temperature. Rate constant depends upon temperature. K increases as temperature increases. It does not depend upon the initial concentration of the reactants. So these 2 points are very important to remember. Rate constant depends upon temperature, but rate constant do not depend upon the concentration of the reactant. Right. Its unit depends upon the overall order of the reaction. This we'll discuss in the upcoming sessions. Right. So in the next session, we are going to study what is order of the reaction, what is molecularity of reaction, and what is integrated rate equation. So I hope the introduction to chemical kinetics and the few concepts that we have discussed in this session is clear for you. So that's all for today. Thank you.